today first program is just write a program to print a number from 1 to 10. Just do a simple one now. See, we are taking the input from the integer, from the user. So, or a number equal to input. Let's say, please enter a number. Now, we are just providing a number, but as you know, this is a string, it won't work. We have to wrap it with int so that it will behave as a number. So int, now it became a number. Now I will just write a for loop for x in range 0 to n. That's it. If you want, you can give 1. That is the step count. Print x. So, if I run this program, let me run this program once. Okay. Okay, sorry. I have not given this colon. Yeah. Okay, so as you can see, I have been asked to enter a number. What if I enter 10? Can you all tell me what will be the output?
Yeah, it might raise an error because the second number in the for loop is n. Okay. So yeah, it's starting from 0, right? But the n is not it's not defined. Yeah.
But I have defined n in line 529.
Oh, okay.
This is how you take the input from the user. So see the message it has written. Please enter a number. Whatever I'll enter, I have entered 10 right now. See, I have entered 10. So this will be assigned to n, and n can be used. So this is dynamically done.
Okay, that's n. Okay.
That won't throw an error. You consider it as 10 now because I have entered 10 here. So what will be the output?
It's going to be like 0, 1, 2, 5, 4, 7, 6, 9.
0, 1, 2.
Yeah. 0, 1, 2, 3, 4, 7, 6, 9.
7, 6, 9. Why 7, 6, 9?
So it's before 10, right? You had to count down 10.
Okay.
Yeah. And the second number 1 means like steps. Yeah, right? Like you mentioned. Yeah. So it's going to jump like 1 by 1. 0, 1, 2, 3, 4, 5, 6, 9.
Okay. What about Hamik? Stephen, Hamik, what will be the output?
The output would be 0 to 9.
So I'm running this program. See, it's printing from 0 to 9. Okay. So here n is defined and taken as an input. So that is why if you give 20 here, it will take 20. Till 19, it will take 0 to 19. That is 20 numbers. As I mentioned, that final is -1. Always it goes from initial to final -1. So Mike, are you getting this? How the n is being assigned dynamically?
Yeah. I got it right now. Yeah. Before I saw it, the n is not defined.
So this is very important. This part, int, this is converting it to a number. So if I am removing this,
it will raise error.
Yeah, it will treat it as a string. Let's say I'm providing 10. See.
Oh, yeah.
Why? Because for loop is expecting a number from 0 to 10. But 10 here is a string. It is not a number anymore. It is considered like this, 10, string. Not 10. So we have to convert from string to this. From string to a number. That is why what we did is, we have just taken int, typecast. This is known as typecast. Whenever you have to play around with numbers, you have to typecast it.
Gotcha.
So once this is done, okay. So this is just a simple example I've given. So now we will work on some sample questions. So I'm writing the question. You all have your PyCharm. You can all try. I'm just writing the question now. So this is what you have to execute using code. So you all try your code, how to write it, and just paste the solution in the chat. Yeah, 55. So Mike.
Yeah.
That's cool. You did whatever was asked, but you can always use the input function and try, because it will help you to make it dynamic. You did whatever was asked in the question, but still you can use this, like s equal to 0, and here n plus 1.
Oh, n plus 1. Okay.
Got it, right?
So I just enter from 1.
Enter 10. Enter 10. Here, when I run the program, it is asking the input from this line, from the user.
Okay.
So now I made it more generalized. So if I'm giving 10, I'm getting 55. I made it a calculator. Your program only calculated from 1 to 10. If I will give here, I can give 20 to find out the sum. So it became more generalized. See, this is your program.
I saw my mistake.
Yeah. You used rhyming words. That is why I got confused. So here it will be num. Rest all is okay. Even it's not okay. See here.
Yeah, it works.
Here you have a different indentation problem. See, indentation. It seems that inside for loop you have print statement as well, which is not true. Your print statement should be outside the block. So it should be outside, like this. This is different. Now it will work. But still you have a I in range, sum equal to sum.
It works in my machine.
Let me check. Num 10, what is the error? I. Oh, indentation error. See, that is the reason. This is okay. Now, here. See, it is working now. There was an indentation error apart from that, or it wasn't organized well. No, it is okay. This statement belongs to this for loop, but this statement is outside for loop. That is important. See, if you see the answer changes if you put it inside. If you put it inside for loop, see, this is how it will look. It will print you every output of every stage, how the loop is working. First it is 1, then the sum is 1. Then sum became 1 plus 2, 3, then it is 3. Again 3 plus 3 is 6, 6. And 6 plus 4 is 10, so it is printing 10. So the output changes if you do some changes with the indentation. So this I removed it from the for loop and taken it outside. So now it works, gives the single output. Otherwise it was inside the loop, it is rotating every time and printing how many times the loop rotates. That's okay. So I hope you all got it. It worked. Now we'll move on to the next question. Simple one. Similar to that, though. Write a program to find the factorial of first 10 natural number or first of natural numbers of a natural number of a number input entered by user. So the concept is multiplication instead of addition. One, two, zero. So this is the question. Please try it.
Both. I have the reply, but I don't want to put it because I did it before, as I told you.
You did it before. Okay, cool.
Yeah,
so you got the answers, right?
Yeah, already.
Cool.
Should I put it in the chat?
Not required though. If you have done, the answer is coming this way. So you need to know the difference, right? It is similar to the sum. You see the previous, let me write it down. So Mike, this will be n plus 1.
Yes.
Okay. So if I'm running it, now if I'm giving 5, it's giving 120. If I'm not giving n plus 1, it will go till 4, even if you provide 5.
Because it's always going to minus 1, right?
Yeah, final position minus 1.
Okay, got you.
So actually, range, let me see.
Stop it, 别这样好吗？
I don't know. Maybe I'll see it later. So whatever it, see, the thing is here, when you compare the sum, you just see this sum. Sum here, you have taken sum. For taking sum, you have to write else equal to 0. You have to start. For product, you have to take 1. Because if you multiply something with 0, it will become 0. That is it. The rest of the concept is same. Can you see both have so much similarities? So only for sum you're taking plus, here you're taking multiplication since you have to do factorial. And whatever you have to accumulate, for that you need a variable. You have assigned it to initialize it with 0, and here you have initialized with 1. Because if you put it 0 here and you run it, the answer will always be 0. Anything multiplied by 0 is 0. That is why to avoid it, we have taken 1, because in product, this 1 is the neutralizing value. Are you all getting it?
Yes.
The difference. Yeah. We'll move on to the next question then. I posted the question. It's a very easy question. Just try it. You have to take the input from the user, and then based on that input, you have to decide whether it's even or not. You have to use if-else program and elif ladder as well. So if somebody is giving the input as A instead of a number, so it will show wrong input. This should be the output that will be displayed in the screen. So if I'm entering 5, it will show. If I'm entering 6, it will show even. If I'm entering 7, it will show odd. If I'm entering A, it will show wrong input. So the hint is you have to use if-else ladder, else-if ladder, if-else-if-else ladder. Yeah.
But when I'm trying to use when I'm trying to type letters, which is I expected the wrong input, but it's actually showing mistakes. Saying that invalid literal for int.
Let me see. If I'm giving 12, so you get an even number.
But if I put like letters or
13 odd, okay. Oh, I'll give A.
Yeah.
This is because for this.
Oh, okay. I only
converting the character.
So
let me check now. A. Now this is the error they are giving because this is considered a number, right? They are doing a
Right.
modulus operator on a string. It is not working. So here you have to do one more thing. Like,
If I gotta put int
yeah,
on before the end. Okay, yeah. Parameters. Okay.
or you can do one thing. You can do that only. That's better.
Yeah. So put both in. Okay.
Let's see if it works. What's the point here? Int modulus 2. Invalid control. For int. Oh, from string to int you cannot convert. Even this is a, right?
Yes.
You cannot do that. So first you have to make a condition here. See how to find out a logic. You have to build a logic now. How to avoid this problem. So let's say we'll write if, okay, n is greater than equal to 0 and n is less than maybe less than 10 or 9. You can write, or the digits is, if it belongs to a number, you have to write like that. Think of a logic, else it is, okay, wrong input. Let me write. Alphanumeric n dot is digit. Let me see. We have some more alpha.
Oh, what does this means? And
alphabet or not. Let's see what it prints. Okay.
Okay.
We'll just check this now. Let's do a debugging operation. Let me comment it out. So only we'll run this and check. We'll build the program based on this. Stephen. Hi, Stephen. Are you there, Stephen?
Yes, sir.
Yeah. So this one you can try and see why it, have you done this wrong input part? If you provide an alphabet to your program, does it work? And show wrong input?
No, I haven't tried it.
Okay, so you just see what I'm doing right now. So I'm taking an input. Let's say here I'm taking 5. See, it is showing false. It is alpha. No, it's not alphabet. Is alpha. With this function, we are checking whether the input that has been given is alphabet or not. Is alpha dot n dot is alpha. So it is showing false. That means it is not an alphabet because it is 5. Now I am providing a. See, it is showing me true. So based on this condition, I have to create the other program. So what I'll do, I'll take a if condition here. If n dot is alpha, that means I will check whether it is alphabet or not. If it is alphabet, then I will write wrong input, else I will do the rest of the thing. I have to take this here. This is not required. So this is the new program. Let's see if it works or not. 5. What is the problem here? Oh, 5 is modulus 2. Oh, okay. I've removed the integer thing. So else n equal to, here I have to give int. Because it is treating 5 as a string now, because I haven't done the typecasting. So now see odd number. Now I'm doing 6 even number. And I'm giving an alphabet. Let's see, A, wrong input. See, the question has been resolved now. So Mike, did you understand how this is being done?
Yes, you have to put the n alphabet to determine its yeah, it's the alpha.
So it's kind of, we have done a nested condition inside a condition. So first we are judging whether it is deciding here whether it is an alphabet or numerical. If it is an alphabet, this will be printed. If it is a numerical, then this section block of code will be executed. Further, when we reach this block, we got an error because I didn't typecast it. Because in this block, it is considering the input as number. And in this block, it is considering the input as alphabet. So for alphabet, we didn't have to typecast. As I already told you, whatever you enter in the console, it is by default string or alphabet. So that is why here it didn't require any type conversion. But this is for numerical value. So that is why we needed this int for type converting. Even this is not required. You don't need this as well. You can just write else. It will work.
So we have 2 else. Oh, we have, oh yeah.
It's like if and else, inside this else, there is an if and else.
Okay.
This is called nested if. Based on your condition, you can give, say, I'll give 5. See odd number. How it happened? See, here at this stage, 5 got saved. Then at this line, it checks whether 5 is alphabet or not. It is not alphabet. So it moved to else part. Yeah. From else, it converted that 5 into integer. Then saw it is divisible by 2. It is not. Then again, it jumped to else part and printed this. Because either it will be a even or odd. So why to check separately for odd? You don't need to give condition. Not required.
Got you. So we have to write the if is alphabet at first, right?
Yeah, because in the beginning only you have to decide whether it's alphabet or numerical. That is why the error is coming, because they cannot judge it. We have to decide and tell them. Because for numeric we have to do a typecast, right? That is the reason it is getting an error. Because it won't understand. Python doesn't understand. We have to tell them that okay, this is an alphabet. For that you have to just write other statement, and if it is a numeric value, for that we have to do some operations. So for that we have to convert it. So whether to convert it or not, we have to decide it before doing the operation. So that is why this statement decides whether it is an alphabet or not. Then what steps do we have to take based on that, the decision that they make. So based on this, we either be a alphabet or be a numerical value. So that is how it is divided.
Got it.
Kind of a flow chart. So Harmik and Stephen, did you understand?
Yeah.
So if you tweak a little bit the question, the entire program changes. Even odd was simple. Okay, but this is a practical example, because what happens sometimes while filling a form, maybe an admission form, you have been asked your age. So you will have a input or a form field where you have to enter the age. Obviously you will enter in numbers like 1, 2, 3, 29, 25, something like that. But what if someone enters A, B, C just for fun? So the application may crash if you don't write certain programs like this, because this is called handling of the errors or the validation, proper validation of input. So this is how you have to write in your websites when you program. You have to think every possible thing. Like if you have been asked an age, if you're writing dollar or percent, a special character, then also you have to avoid it. You have to say that it's a wrong input. Kindly input again. So this is kind of a practical example. Then,
boss.
Yeah. In
case of we'd like to write only the letter, but if I want to report in the form that this is not a numerical, that it will be dots is numerical.
Yeah.
Okay.
You see, in PyCharm, this helps. If you put your cursor after the dot and press Control space, you will get the whole list of operations that can be done. So here you can see there is alphanumeric is also there, mix of alphabet numerical. Only numeric is also there. Only numeric you don't need. If you have alpha, then opposite to it is numeric. So any one if you get, it's all the same. See, is digit. This is called numeric. Is digit from 0 to 9. Is numeric is there for number. If it is a decimal number, it will have is decimal. So you have all of them here. Got it?
Got it.
Yeah. So next is check whether a number is Armstrong number or not. Okay. Write a program to check whether a number is Armstrong number or not. For example, if I'm inputting 153, this is Armstrong number. If I'm inputting anything else, 100 or 100 something, not an Armstrong. And what is the definition? Armstrong number is actually sum of the cube of digits. Sum of cube of digit. That means one into one plus 5 into 5 into 5 plus, I think, let me see, it's actually 1 into 1 into 1 plus 5 plus 3 into 3 into 3. If you do this calculation, it will give you the number itself. Sum of its digits cube. If you add it, it will give you that number itself. This is what you have to check and write. Hint is you have to use while loop. Whenever you are asked to play with the digits of a number, always use while loop. This is very important concept. Every digit related questions will be done in the same way. So try it out. Let me also write it meanwhile. So yeah, Mike and Stephen Harmick, Luo. So
Yeah.
I just wrote the program here. So as per the definition, it says that Armstrong number usually are 3-digit numbers, and they will always have a cube. Okay. So Mike, you were correct about the 3 digits. So it's fixed actually. It only has 3 digits, and you have to find it accordingly. Like for example, 153 is an Armstrong number. 371 is also an Armstrong number. So if you Google the definition, it's like an Armstrong number is 3-digit number in which the sum of the cube of its digits are equal to the number itself. So, so that's now I will show you. This is the program that has been written here. And here you can see if I run this program, it's showing, let's say I give any random number. It's not a Armstrong, but if I give 153, it is showing Armstrong number.
Okay.
And if I'm giving 371, it is also Armstrong number. So now I'll explain you how it worked. Okay. Let me share my screen. So now what happens here? For example, if I've taken a number, let's say the user takes a number as user takes a number as 153. When you run the program, it will ask you enter the number. So you will just enter 153. Now what happens? When you enter 153, this value in n, you will in this value num will have 153. So I am just passing, I'm taking one more temporary variable where I am passing this value. So now now n is equal to 153 in this case, and num is also 153, n is also 153. Now what happens? As we have seen, s is taken as 0. This is for calculation of sum. Now I'm starting the loop at this point. So I will check while n is not equal to 0. That means, so I'm checking 153 is not equal to 0. Yes, of course, it is not equal to 0. This gives a true. So it enters the loop. Here it enters, first line. It calculates d. D equal to n modulus 10. N modulus 10 is your 153 modulus 10. If you divide 153 by 10, you will get 150. 15s are 150. So you will get 15 as a quotient and 3 as a remainder. So modulus operator returns you the remainder. So d will store 3 here. Now d is equal to 3. This is the first iteration going on. First iteration. First time while is rotating. So d has been calculated. Now next is s. Sum equal to sum was 0 initially, 0 plus whatever d you have calculated 3, that will be cube. D to the power 3 to the power 3. This is the meaning of double star exponent. So sum will be sum 0 plus 3 into 3 into 3. That is 3 is a 9, 9 is a 27. So s will be 27. Now it will go to this part. N equal to n by 10. What was n? N was num. So num n equal to 153. Num was 153 by 10. And double divide means it will take only the value which is the integer part, not the decimal part. So if you just divide it, it will be 15.0. But if you are double dividing it, it will only take 15. So now n value is 15. So this is one iteration. Okay, this is one iteration happened just now. One. This is the first iteration happened. Now the loop again, once this is done, the loop again goes for the second round. Again, it checks here. N. What is n right now? I told you n is equal to n double divide 10. That is 15. N is now 15. It goes there. When for the second round, it will check again. N is not equal to 0. Yes, it is. 15 is not equal to 0. Second case. It is always true. Again, 15 is not equal to 0. True, obviously. So again, it will go inside second round. N modulus 10. Now it is dividing n. N is 15 now. 15 divided 10 is 1. So, and the remainder, what we are getting? 5. 5 is the remainder. 10 ones are 10. 5 is the remainder. If you divide 15 by 10, you will get remainder as 5. So D will be 5. Similarly, S will be 27. S was 27. So 27, S equal to 27 plus what was D in the second round? 5. So 5 cube. So 27 plus 5 into 5 into 5 is 27 plus 125. Now N is 15. So 15 equal to 15 by 10, that is 1. In the second round, 15 by 10 is 1. So now N is 1. Now this goes again for the third round. Now it goes for the third round. Okay. Now after it reaches here, it goes for the third round. So third iteration is like N is not equal to 0. So N is not equal to 0. Yes, of course, N is 1. 1 is not equal to 0. It is true. So it goes inside for the first round. It goes inside for the, third round. This is the third round. It is going D. D equal to 1. N is 1. 1. If you divide 1 by 10, you will get the remainder 1. Because 10 zeros are 0. 1 is the remainder. So D is 1 now. Similarly, S will be, S was 27 plus 125. Now here it will be 27 plus 125, which was already there, plus this D cube. 1 into 1 into 1 is 1. So S is 1. N will be now, N will be 1 by 10. 1 by 10 will be 1 by 10 will be 0. Because 10 zeros are 0, 1 is the remainder. It's 0.1. That is why N will be always the 0.1's 0 value will be taken, ignoring the decimal point. So N will be 0 now. Now for the third iteration, now N is 0 here. Now it will go here for the fourth iteration. While loop, it will check N is not equal to 0, but N is equal to 0, right? This time. So it will kick out of the loop, come to this. It won't go inside this anymore. Now it will go to this if. So the iteration ends here. Now this if will check the sum. This sum 27 plus 125 plus 1. If that is equal to the value which has been entered when the user inputted it. So if you add this, it becomes 153. So 153 is equal to num. Yes, true, it is num. So it will print Armstrong number. Did you get it?
Yes.
Just realize every time what is happening when you entered 153, it first extracted the last digit 3, then took the cube of it, then extracted this, took the cube of it, then extracted this, took the cube of this. See, it is going from the back side. Whenever you have anything to play with the digits, if you take this formula, just remember this as a formula. Always you can do, like I'll give you a new program now. See, write a program to find sum of digits. For example, if you have 132 is the input given by user, and I want the output as 1 plus 3 plus 2 equal to 6. I want this as output. How will you write the program? You will just write like this. You will take the input, n equal to int input, enter number. You have taken the input. Just take sum equal to 0 while n is not equal to 0. D equal to n modulus 10 and int. Typecast it. D equal to int. N by 10, then S equal to S plus D, N equal to N by 10. So come outside and print sum. You will get this answer. See, you see this formula is common in the previous case. Why? Here what happened? When I am inputting 132, what it is doing is taking out 2 at this stage. Then again it is taking out 3 in the next iteration. Then 1 and adding it up to 6. This is how the digit related programs are done. You have to remember these 3 lines. You have to manipulate this portion based on the question. See, it was sum of cube. That is why you added cube. This is just sum. So you have just added this. You haven't done anything else. Here you haven't done anything because I have just asked for sum of individual digit. In the previous case, I was asking cube, so you just did here cube. See, you have just changed this, rest all are same. Okay, one more thing. Here I have just asked you to print the sum and you printed it. But here I asked you whether it is Armstrong number or not. So for that, you have to check this sum, compare it with the original number you have inputted here. But see, if I have not introduced this, if let's say I'm not using this line, if I'm using num here, here also num, here num, everything num. Here you see at the last stage num has become 0, right? So if you compare num here with that sum, it will always be 0. That is why I've taken this as a copy. That is why I've taken this a copy so that in future I can compare it with this sum. That is why I've introduced this line. This is kind of a temporary variable I've taken. Just this num can be used later on to compare it. Otherwise, because if I take the same variable and use it, this num is getting reduced every time. From 153, it became 15. Then next time it became 1. So 0, sorry, it became 0. So if I would compare this same thing here outside, the sum would have been compared with 0. That is why I've taken this line. Are you getting it?
Yep.
Yeah. So this is a very important concept, and based on this, you have questions like Armstrong number is one of them. You can see palindrome number. You can check Pascal's number. There are different type of number related questions. So in the next class, you just try and come with the palindrome number. Example 1 to 1. See, from both sides it is 1 to 1. If you reverse it, it is 1 to 1. So your concept will be reverse the number and then check whether it is same or not with the original. Similar concept like this. Only you don't have to do this operation. Okay, this is what we'll do. You have to write a program to check whether the number is palindrome or not. That means if you are reversing the number, for example, 1 to 1, if you reverse the number, it will appear to be the same number from both the sides. So the concept here is you have to take the approach of taking the number as an input and then reversing it and then checking whether the number that you got after reversing is equal to the number which you have received as an input at the beginning. So that is the concept here. So use the concept, ask the number from the user as an input, then apply the logic of reversing the digit using the logic as I shown in the previous day as in Armstrong number. Then finally come out of the loop, use if statement to check whether the original number is equivalent to the final number or not. Then you can print yes, it is palindrome. So this is the logic. So just try it out and share your solution in the chat. So let's start this solving. So just see here, I will use the Armstrong number solution and I will just modify it to get this answer. Okay. See, I have just copied the Armstrong number solution and I have pasted it here. Now I will just edit. See, first line is required. We need an input. So this is correct. Now, then I'm assigning it to a different number because we will reuse that number here. So it's better to keep it that way. So then we have started the while loop to extract the digit. The first digit that will be extracted using this number. Then, as per definition of Armstrong, it is when we get the digit, we usually cube the digit, find the cube of the digit, then add it. Here we don't need that. We need to multiply 10 with that and add the digit. That is the concept. So here you have to write, instead of S, I will take R, reverse. Let's say rev is a variable that I have taken. You can take S also, it's up to you. Just to remember or differentiate it between Armstrong and palindrome, I'm just taking rev. Rev means reverse. Rev into 10 plus D. So this is the formula here if it's palindrome. That's it. Let me run the program now. Okay, 1 second. This S should be rev, as I have changed everything to rev. See, I am giving something like this. It's showing 232. See, 232 is a palindrome number from either side. Let's try something else. 1 1 2 3 4 5. See, not a palindrome number. So what did I do? I just changed this line, which is the formula for Armstrong. And this was the formula for Armstrong, and this was the formula for palindrome. The trick is here, rest all the concept is same. So I will tell you the concept, how it worked. So this is the only thing you have to remember. So what happens here is, let's say you have entered 121 as a number. So in the first iteration, okay, in the first iteration, at this point, it will check 121 is not equal to 0. It's true, it is not equal to, it will enter to the next line. At D, you will get 1. So N is 121, num is 121, rev is 0. This is just a variable with a counter. Like for sum, we take S equal to 0. For factorial, we take F equal to 1, kind of initialization. Now, D will be 121 by 10. That is 12. The integer value of D will be 12. But you have taken modulus, which will return you the remainder. That means 1 will be returned. So D will be 1 in the first case. Okay. So D will be 1. Then it will go to rev. What is D actually? D is actually the last digit of the number. This is D, last digit. So once I got D, I will calculate reversed value. I will just multiply that with 10. 1 into, rev is 0 now. 0 into 10 is 0. 0 plus D will be 1. So rev will be 1 in the first iteration. Then as usual, n equal to n by 10 will divide, and n will be 12 now. 12 by 121 by 10 will be 12. Only the integer value will be taken. So this is the first iteration happened. Now again, now n is 12. It will go for the second round. Second round, 12 is not equal to 0, right? 12 is not equal to 0. Then it will go here. Again, it will check. So again, it will check. 12 is not equal to 0. Then it will calculate the digit. So modulus 10. If you divide 12 by 10, it will be 1, and the remainder will be 2, right? Remainder will be 2, quotient will be 1. So you will get D equal to 2 in the next case. That is actually the second last digit, 2. This is the 2. Now just see what will be rev. Rev was 1 initially. 1 into 10 is 10. 10 plus D is 2. So it will be 12. 1 into 10 plus the new D, that is 12. And N will be 1, because 12 by 10 is 1. So it will get this. Now we will do the third iteration here. 1 is not equal to 0. Yes, it is not equal to 0. Then it will go here. It will divide. If I divide 1 by 10, it will be 0.1. Remainder is 1. So in the third iteration, D will be 1. Rev is 12 now. 12 into 10 is 120 plus D. D is 1. D is 1. Rev will be 120 plus 1, that is 121. So you see the number got reversed. And N will be as usual 0, because now 1 divided by 10 will be 0, integer part. Now it will no further, it will not go inside the while loop any further. It will come out of the loop, it will come to this part. Now it will go to this part. It will come out of the loop. Now it will check rev. Rev is 121 now. Rev is actually equal to the number which you have inputted, that is 121. Yes, it is. Then it will print palindrome. Otherwise, it won't. So Mike, did you get it? How it worked?
Yeah. Yeah.
See what it is actually doing. 121, right? It took 1 from here.
Right.
First, it took rev, a container where it is taking 0, rev is 0, multiplied 10, added this 1 here, 1. So it is 1 now. Again, rev is 1. So 1, next time 1 into 10 is 10 plus it took this number and added here 2. So 1 into 10 is 2, that is 12. Now, in the second case, it took 12 into 10 plus this one, 1. So it is 120 plus 1 is 121. See, when it is extracting a number from here, I mean, if 121 is there, if it is extracting a digit, in order to add the next digit, it needs to be multiplied by 10, so that if you add some digit, it will come at the units place, in the last place. So similarly, 1 is multiplied by 10, got 10, then added 2. So here again, it is adding 2, it is becoming 12. Then again, 12 is multiplied by 10, that is 120 plus 1, it is 121. So this is how it is doing. It is taking the digit, multiplying by 10, adding this to it, multiplying by 10, adding this to it, and then checking whether it is same or not. If you want to reverse something, this is the concept you have to do. Are you getting it?
Yeah.
So basically, to play with the digit, you need this one. You need this and this. And in between, you have to just write the solution based on what is the question. For Armstrong, this changes because there we need a cube, right? See here, this was Armstrong number. Rest all were similar. S equal to S plus D cube. So for Armstrong, it is S equal to S plus D cube. For palindrome, same thing becomes rev equal to rev into 10 plus D. You can write rev as S also, it's up to you. Just to differentiate, I've taken a new variable. You can use S as well.
So all we have to do is change the middle of the line, huh?
Yeah,
the code.
yeah.
The first and the last, we don't have to like change it. We just have to remember it, huh?
Yeah. We all are playing with the digits. So in order to play with the digits, you need to extract the digit by modulus and then divide it with n equal to n by 10 to get the quotient. Revolve it in the loop and keep extracting the digit from the back end. So in between is it's up to the question what has been asked. Based on that, in the formula, you have to play with the digits. Whatever you require, you can do that. So I will again tweak a question and ask you to just, I'll give you one more question. You can also solve it, and you will find it similar to these two. So this is the next question. The question is, find a number whether it is a Harshad number or not. A Harshad number is something where you have to extract all the digits and find the sum of all the digits and see if the original number is divisible by this number or not. This is the concept here. For example, you see 18. If you see the digits of 18, that is 1 and 8. If you add 1 and 8, it's 1 plus 8 is 9. And so 18 is divisible by 9, right? If you divide 18 by 9, you will get remainder 0. So that is the concept here. You extract all the digits, sum it, and then divide the original number to see you get the remainder 0 or not. Then it is known as Harshad number. It is similar, very similar. You have to tweak only 2 lines in the original previous codes. Just try it on and share the solution in the chat. So I'm just sharing the solution now. So I'm just taking the previous solution and editing it. So in this line, we are taking the input. Then we are just keeping the input in a temporary variable. Then let's take it as S. Since we are doing the sum of digits, let's take it S or sum, anything this way. We are just extracting the digit, last digit. Let's say for 8, for example, in 18, we are extracting 8 in D for the first time. Then instead of ref, we just need a sum equal to sum plus D. Now, once this is done, while checking, instead of checking equivalence, we have to just check whether the number that we have taken is divisible by the sum that we did just now is having remainder 0. That's it. Program is done. So if I'm running this program, $18, so it is giving me the value. If I am entering some random number, it's not a hash. So I just edited this and this condition, and this line number 630 and line number 634. I've only edited these two lines. So similarly, in this case, you can also get other questions like find the sum of the digits. Simply, they will ask you find the sum of the digits. So you will just come out of the loop. You don't need any if and else statement. You have to just print the sum. So that is how you can answer multiple types of questions based on the logic that I just showed you. So, for example, you have Armstrong number, palindrome number, and this Armstrong number. All of them, have the same structure of the program. Only the thing is you have to change either of the two lines at max. So, I am just moving on to a new concept of questions, and here the number related questions are over. Whenever you get any number related questions by like reversing a number or playing with the digits, always apply this structure. So now we'll move on to a different question where we have to use for loop here. And also remember that it's easier when you play with the digits. You always prefer while loop instead of for loop. And in other cases, just use for looping. So I'm writing the next question that we're going to discuss. That's a prime number. So I want all of you to just write the solution and share it in the chat box. So here is the question, and I'm just sharing it in the chat box. Try to find the answer and share it. So what is prime number? For example, if you take number 5, so it is either divisible by 1 or the number itself, that is 5. It won't be divisible by 2, 3, 4 or something like that. So the hint here is you take a loop from 1 to the number itself, then you can keep dividing it and checking whether you're getting the count 0 or not. If you get the count 0, then you know that it didn't get divided by any of the numbers in between 1 and 5. So that's a prime number. Just try it and share the solution. How the class 6? I will run 6.
Boss?
Yep.
Yeah, I'd like to share my mistake. I think if you try to edit it, it will be good for me to understand it more. I'd like to share it like that.
Sure. This is the solution that Luo gave me just now. Let me edit it and fix it. Then I will take your answer and I will edit it. You can also see what Luo did here. Luo, since you have used a print statement inside a loop, that is why you are getting multiple prints. Print statement should be outside the loop. So what Luo did is, Luo took the range from 2 to n minus 1. That is, if you are taking 5, then he has considered it from 2, 3, 4. That's it, 2, 3, 4. From 2 to less 5 minus 1, that is 4. So 2, 3, 4. Then in the program, the number is being divided by those number and checked whether it is divisible or not. So you can do one thing here. If you just divide the number with all those digits, all those numbers between 1 and 5, and see if it is 0 or not. See, if it is 0, then you can just break it out. That means not a prime number. One second. Print, we cannot write print here. We can take a flag instead. If I is equal to 0, maybe not equal to 0, then it's okay. You can take a counter here. Counter equal to 0. Let's say you can write counter plus plus, or maybe counter plus equal to counter plus 1. Now you're coming out of the loop here. If the counter equal to 0, prime number, else it's not a prime number. So I'm running this program. 5, prime number. 4, not a prime number. So the concept that I used here is, I have divided the number and divided the number by each of the numbers in the range from 2 to the number minus 1, and then checked added every time if it divides and gives remainder. Since, for example, 5, if I divide 5 by 2, I will get remainder as 1. I won't be getting remainder at 0. So it won't count anything. Counter will still remain 0. So if I'm dividing with 3 also, it will be counting 0 only. Even for 4 also, it will count 0. It won't be going to the if statement. So when I'm coming out of the loop, I will compare whether the counter is still 0 or not. If it is still 0, that means it's a prime number. Else it is not. So this is a concept which you can use to find prime number. Now, Hamik, can you share your solution in the chat box?
Hey, boss.
Yep.
Can you copy the code to the chat box?
No, let me give you the code in the chat box. Here it is.
Thanks.
Yeah, you can check.
Okay. Yeah. So Harmik, can you see your solution in the screen?
Yes, I can.
So you have taken the number, you have taken sum equal to 1, and then you have taken the range from 1 to n. Let's say you have taken 5 as n. So first time 5 will be divided by, okay, I is divided. Where is n? If you divide 1 every time, I is the loop, not the num. You have to use num here, right? Here will be num. You have to divide it by I. Okay. And you have to use sum here. Sum. If you write print inside a statement, it won't work. It is a loop, right? Every time it will print. It is prime, it is not prime. So you have to just take a counter and add it. Like this. So you can take this 0 or 1, whatever you want, 0. Then you can get out of the loop. Then if that sum that you calculated is equal to 2 or 1, it will be 1 in your case. Why? You have started it from 1. Because if you divide the number for the first time, I will explain you how it is working. This will be print prime, else not prime. Okay, now I'm running this. Just see how it works. 5 prime. Now I'm giving some other number, 6, not prime. Here what happens, you started the range from 1. So for the first iteration, it will check that num is 6, right? 6 modulus 1 is equal to 0. Yes, it is. So it will add sum equal to 1, sum plus 1, that is 0 plus 1. Sum is now 1. It will again go, because it is a range, so it is a loop. So next time the I becomes 2. So again it will check 6 modulus 2 is equal to 0. Again it is divisible. So sum will become 2. 1 plus 1 is 2. Again it will go 3. I will be 3. Num is 6. 6 divided by 3, it will give 0. So it is satisfying. Again sum will be 2 plus 1 is 3. So when it will come out of the loop, it will see it is not equal to 1. That means it is not a prime number. Now if we take the case of 5, if you divide 5 by first iteration, it will be 1. 5 will be divisible by 1, so sum equal to sum plus 1. Next time 2. 5 is not divisible by 2, so it will not add anything to the sum. Again it will go try next time. 3. 5 is divisible by 3. No, it is not. Again it will go. 5 is divisible by 4. No, it is not. Then it will come out of the loop, because n, you have written n here. That means it will go till 4 if it is 5. N minus 1. So from 1 to n minus 1, only one time it is going inside this loop, because it is divisible by only 1. Rest of the number is not divisible. So that is why sum is always 1 in case of prime numbers. That is why it is showing. So Harnik, are you getting it?
Yeah.
So Mike, did you get the solution? How it is done?
Yes.
Shall I explain it once more?
Yeah, please do.
So what happens here is, let's say num is 5. So n is equal to 5 because you have assigned it immediately. Sum is a kind of counter you have just taken to add it. So 0. Now what we are doing in the loop. See this, what does this mean? This means I have a for loop, and with this range, that means the loop will have a value of I. Value of I will be 1 in first iteration, then second is 2, 3, I will be 4. Till 4 it will go, since it is n minus 1. If you have given 5, 5 minus 1 is 4. So in the first iteration, let's say this is the first iteration, I equal to 1. In case of I equal to 1, I is 1, num is 5. 5 modulus 1. It is divisible, so it will give 0. Yes, so sum will be equal to 1. Since it is 0 here. So in this iteration, sum will be 1. Okay. It will go again, because it is a for loop, it will rotate again for I equal to 2. When it is 2, 5 modulus 2 equal to 0. No, it is not equal to 0, not. So sum, it will not go inside this. It won't go inside that. It will again rotate. So sum is still remaining 1. In case of 3. So now I am dividing it with 3. Same condition, it won't give you zero remainder. Again, it won't enter here. Sum will still remain 1. So again, in the second case, if you just try 4, next time 4th time also, it will be show the same condition. So S will be still remaining 1. Now this range of looping is over because we have only 4 chances. Now it comes out of the loop, goes to this place, checks it is equal to 1. Yes, it is equal to 1. So it is a prime number. So 5 is a prime number. Okay. Let's take a second condition now. Let's take it 6 here. Instead of 5, we are taking it 6. N is 6, sum is 0. For first iteration, S will be, let's say 6 comes here. I will go, in this case, I will go to 1, 2, 3, 4, 5. Because n minus 1 here now, n is 6, so 6 minus 1 is 5. Till 5 it will go. And in every case, we will check what is S. So for the first time, I is 1. So 6 modulus 1. Of course, 1, if you divide 6, any number with 1, it will be divisible. So it is equal to 0. So it goes inside S is equal to S plus 1. So 0 plus 1 is 1. S is 1 now. Second time, I is 2 in this case. So 6 modulus 2 is again equal to 0. It is divisible. It will give 0 remainder. So again, it will go inside. S was 1 already. Again, it is adding 1. So S becomes 2. Then again, it goes. Now I is 3. So now I will be 3. 6 modulus 3 equal to S plus 1. Again, it is satisfying the condition. Third time. So again, S is 2. S was already 2. Now it became 3. Again, I becomes 4 now. Next iteration, I becomes 4. Next time, again, it became 4. 6 modulus 4 is not 0. It won't enter. So S will still remain 3. Then again, it goes till 5. Last iteration is 5. It goes here. 6 modulus 5 is not equal to 0. So again, it won't go inside. S remains 3. But now, since it is over, it will come out of the loop. It will check it's equal to 1. No, it is not. It is 3. It is not 1. So it will print this, not a prime. So you can see any number, if you divide and see, check if it is equal to 1, then only it will be prime. Otherwise, in any case greater than 1, it will never be prime. So we will move on to the next question. It's similar to this prime number concept. You can reuse that code and do some editing. So you can get the answer. Just tweak a bit. Try it out. Then I'll explain. So let me just run the program once to cross check. Yeah, that's correct. So, Harmit, did you get it?
I'm on it.
If you have any difficulty, you can share the solution. I can make the changes there. So, this is the last question for today.
Boss, try to help me to resolve it, because when I try to check, it's looping, but it doesn't give me the normal answer. I don't know if the mistake is worth.
That's okay. Let me try it out.
Oh, I saw.
Sum equal to sum plus 1, not 1i, right? You are doing the sum of the digits. Rest all are okay. Did you get it? It's not sum plus 1. It's sum plus I. You're extracting the number. The numbers and adding them, right? You're not adding 1 every time. It's not a counter. It's the sum of the numbers.
Yeah, I understood where my mistake was.
Yeah. See. Oh, you use that factorial thing. That is why. So here, you have to take this outside the loop. See, number is perfect. This loop is going on and calculating every time and doing the sum. Once the sum is done, then you will come out of the loop and then compare it with the original number. So if you keep it inside loop, it will print every time when the loop rotates. So instead of that, you have to take it out of the loop. Did you get it? Now it is printing like this. Earlier you gave me the solution like this. This is what you gave me. So if I run this program,
Okay, thank you.
it's not working like this. Let me check. Okay. Here it is. This is what you gave me. And see, it is printing every time because this print statement is inside the loop. It's still not outside the loop. It should be outside the for loop. So I have to just press backspace and make it outside the loop. Now it will first end the loop, then only it will print after calculating the sum. And then it will check. Is it okay now?
Okay, thank you.